Now that we've seen how to calculate probabilities with replacement, when you take out a marble from the bag, you look at it, and then you put it back in the bag. Let's calculate probabilities without replacement. This is when, you take a marble at random out of the bag, you look at it, and you don't put it back in the bag. Maybe you eat it or you throw it away or something. And obviously, if the first marble you draw is a red and you throw it away, the chance that the next one is going to be a red is pretty slim because there's only one left in the bag. So the probability changes with the second marble that you draw. Let's see how it works. First, I'm pulling out two marbles here, so let's look at the first marble. What are the outcomes for the first marble? It could be blue or red. So in our tree diagram, either the first marble is blue or it is red. What about for this? Actually, before we do the second marble, what is the chance that the first marble is blue? Well, there are 6 marbles out of 8, so a 6 out of 8 chance that it's blue, which means that there is a 2 out of 8 chance that it's red. What about the second step, or the second experiment? In this one, suppose for the second marble, if I draw a blue first, the second marble could still be blue or red. And if I draw a red first, the second marble could still be blue or red. Now, suppose that I draw a blue marble first. Maybe this one. I drew this one and it's gone now. Goodbye, marble. All gone. Cool. Now, how many marbles are left? 1, 2, 3, 4, 5, 6, 7 marbles are left. And how many of these are blue? 1, 2, 3, 4, 5. So there is a 5 out of 7 chance now that I'll draw a blue marble. The probability has changed because this blue marble isn't here anymore. Okay, actually we'll keep going with that example. So now there's no blue marble. What's the chance of drawing a red out of these marbles that are remaining? The chance of drawing a red is 2 out of 1, 2, 3, 4, 5, 6, 7. 2 marbles out of 7 are red. And we can do the same over here. If I draw a red marble first, let's say this one doesn't exist anymore. It's confusing that my pen is red, but I will. So now the only ones left are these, okay. So if I draw a red first, now that one's gone. What's the chance of drawing a blue marble? Well, 1, 2, 3, 4, 5, 6 out of 7. There are 7 marbles left, and 6 of them are blue. What's the chance of drawing a red marble? There is 1 out of 7. Cool. You might notice that these add up to 1. They add up to 100% or a whole, because we're bound to pick something. They're complementary events. Okay, good. Now we can figure out the probability of each of these 4 outcomes. This outcome here represents getting a blue for the first marble and a blue for the second marble. So the probability is the 6 out of 8 here multiplied by the 5 out of 7 here. 6 out of 8 times 5 out of 7. 6 times 5 is 30. 8 times 7 is 56. There's a 30 out of 56 chance that you get a blue and then a blue. What about the chance that you get a blue and then a red? Well, it is 6 out of 8 times 2 out of 7. To figure this out, 6 times 2 is 12, 8 times 7 is 56. 12 out of 56 chance that you get a blue and then a red. What about the chance that you get a red and then a blue? Well, we can do the same trick. 2 out of 8 times 6 out of 7 is 12 out of 56. And finally, the chance of getting a red and then a red is 2 out of 8 times 1 out of 7, which is 2 out of 56. Very, very unlikely that you will get a red and then another red. Now I can figure out the chance that you'll draw at least one blue marble without replacement. It's a bit like last time, isn't it? The probability of at least one blue is, well, this outcome here matches because I got a blue and then a blue. This one here, does this one match? I got a blue and then a red, so that matches. This one, I got a red and then a blue, so I did get at least one blue. That does match. And this one, I got a red and a red. I didn't get a blue. So I need to add these three probabilities together for these three outcomes. 30 out of 56 plus 12 out of 56 plus 12 out of 56, which is 54 out of 56. We can simplify this. It happens that 2 goes into both of these numbers. And 54 divided by 2 is 27. 56 divided by 2 is 28. So that's the answer as a simplified fraction. And the answer as a percentage is about 96.4%. And that, my friends, is how you can calculate sampling without replacement. In other words, where you pick a marble, you look at the marble, but then, instead of putting it back in the bag, you eat it.